So we'd like to start filling out the information in our table, and I think that by far the easiest place for us to get started is discuss y-intercepts when we're in standard form. So taking a look at this example here, our question is, can we identify where the y-intercept is located on this given parabola? Well, in our first example here, the really nice thing for us to recognize is that since y-intercepts always occur whenever x is 0, it should be pretty easy for us to solve for the location of the y-intercept. All we need to do is set x to 0. What we can see is going to happen every time is that the first two terms, since they do contain an x, will go to 0. The third term, since it does not contain any x, will remain. And it looks like here what we're going to land at is realizing that our c term on the end is always going to represent our y-intercept here. We found this y-intercept of 11 by plugging in x equal to 0 and evaluating the right-hand side. In general, we can see that this will always work here. If we set x to 0, no matter what our other parameters are, it should always be the case that we end up with c, our c term, being the location of the y-intercept here. But before we walk away from this idea here, I am suggesting that we're looking at the y-intercept only in standard form, but I think it's simple enough for us to recognize that this same concept is going to work in other formats as well. If we look at something in factored form, or if we look at something in vertex form, we'll see that the same technique is going to apply here. If we simply set x equal to 0, we will find the y-intercepts. Y-intercepts are locations where we hit the y-axis. The y-axis is always where we have not moved left or right at all. Our x value is always 0 if we are on the y-axis. So we can apply that same concept to factored form. Here we found the y-intercept of -30 for our factored form quadratic, and again in vertex form. And we can conclude here that this parabola has a y-intercept of y equals 9. So it seems like the y-intercept column is the easiest and least interesting column that we can go ahead and fill out on our table here. We've seen that if we are already in standard form, we are always just going to use c as our y-intercept here. The reason that c is always the y-intercept in standard form is because if x is equal to 0, both of these terms go to 0, and all we're going to be left with is c. In factored and vertex form, there's not really anything else different. We saw that no matter what, if you want to find y-intercepts, you always set x equal to 0. And so we can state that as our instruction on how to find the y-intercept in all three of our formats. Now you try a few. Here's 3 quadratics, one in standard form, one in factored form, and one in vertex form. For each, locate the y-intercept. Once you've found your answer for the y-intercept, go to Desmos, graph the quadratic, and see if the y-intercept matches the one that you've found.